Okay, welcome to Midterm Review Unit 2 and 3. We are going to solve quadratic equations and we analyze quadratic equations. So when we're going to be solving the quadratic equations, solving means find out what x is equal to. So when we find out what x is equal to, what we're actually finding out is where it touches the x-axis. That's all it is. That's called our solution. So with each ones, these ones say with technology. So this is our first way of solving equations. So the first way is graphing. Okay, using our calculator. So everybody's going to grab your handy dandy calculator, please. And we are now going to go into your y equals, and we're going to clear everything out. In the y equals, insert the first equation, x squared plus 5x plus 4. So the first thing we're looking for is to see if it touches the x-axis. If it does, then that means it has solutions. So I'm going to take my graph. You bet it does. It touches twice. So if I want to find out what those x-intercepts are, how do I find them on my calculator? Okay, second trace. And then what do I do? Number 5. Now, in order for number 5 to work, I need two equations. So I need to go into my y equals. Do I see two equations? No. What should you always put in the y equals to find an x-intercept? 0, because on that x line, y is 0. So on y2, we put a 0. Now we've got two lines. If you want to see your line more visible, all you've got to do is go over to the left, make this little line twitch, unless you've got one of those colorful calculators. We're just going to hit enter once, and it's going to be thicker and darker. That way we can actually see the difference in our calculator. So when I hit graph, it's going to happen real fast. It's going to graph this first one, and then the thick line goes across the x-axis. So now I can visibly see two lines. So now we're going to go back to our rules. We're going to go second trace, and I want to intersect, number 5. Now, how do we know where the cursor is if you can't see it? What you're always going to look at is look at your x values. Right now my x value is 0, so it's blinking on my y-intercept. So I need to move my cursor to the left using my left arrow. As long as you're over halfway, it'll find the left intercept. But you have to be over halfway. So now you can hit enter 3 times. And the intersection is -4. So I know one of my solutions is -4. Okay? So we're going to write one of our solutions down here. We have x equals -4. And we're going to have another solution, x equals another number. Now, from our graph, we can visibly see it's going to be another negative number. Now, this one is beautiful because there's no decimals. This will be an exact value. So which one do you think that's going to be when it hits that number? -1. And it is -1. So, -1, we're going to plot that down. These are the solutions. They are also called zeros and roots. Why are they called zeros? For the simple fact of going onto our graphing calculator, and what did we put into our y equals? We put in 0 for y2. So every time we want to find an x-intercept, they're going to be asking us for a couple things. They might say it 4 different ways. So the 4 different ways they can ask us for the intercepts, the roots, the solutions, and the zeros. Every single one of those words says, solve me for the x-intercept. That's all it wants. It's saying, where does it touch the x line? Okay? If we take the next one, in order to put it in our calculator, we need to have it equal to 0. Is the second equation equal to 0? No. So that means we have to make it equal to 0. So we're going to move that 30 over to the left-hand side. Now, how do I move a 30 across an equal sign? Subtract it. Good, because it's positive. So we're going to subtract 30 from both sides. All it does is it's going to move that 30 behind that 4. So our equation is going to look like 2x squared plus 4x minus 30 equals 0. So this is the equation that I'm going to be putting into my y equals. Okay? So I'll give you a moment to put that in your y equals and find your x-intercepts, please. Push pause down, play when you're ready. Okay, hopefully you realized that you found an answer of -5 and +3. So we're going to say x is equal to -5 and x is equal to -3. +3, thank you very much. Yes, he's +3. So -5 and +3. If we take a look at letter C, now remember, every single one of these questions under each outcome is always going to be easy, medium, hard, right? So standard of excellence questions make you do a couple steps. So what they want you to do, again, it's not equal to 0. So we need to take everything on the right-hand side and bring it to the left-hand side. Now, do we have to do that? Yeah, you do. You need to make it equal to 0. So, how do you move negative digits across? You add them, because you're doing the opposite. So I'm going to add 15, and I'm going to add 8n squared. So, I've got -3n squared plus 110. Then I move these guys, plus 15 plus 8n squared equals 0. Now you need to add like terms. So I'm going to add up all my n's. I've got 8 and a -3. 8 and -3 are going to give me a 5. So this, I'm just going to write up here, is going to give me 5n squared. And I've got 110 plus 15 to give me 125. So that is the equation that we need to put into our y equals 0, because that's what we were trying to do. So now we go to our calculators and we're going to graph this one. We could also solve this one by factoring as well if we wanted to. So back to our calculators, we're going to insert 5n squared plus 125. Plus 125. There we go. Whoopsie. 125. All right, let's hit a graph. Do I see my graph at all? No. So whenever you get into a situation where you can't see your graph, the fit graph is zoom 0. So zoom is the top in the middle. So we're going to hit zoom 0, and that's going to show me part of my graph. It doesn't always show you your entire graph. So sometimes you have to make sure that you raise either your y-axis or you extend one of your window maximums, okay? In this one, when I hit zoom 0, I can see the entire graph. But does it touch the x-axis? No. So this guy has no solutions, okay? So you would write no solutions for this one. So, thinking back, we have now figured out the easy, medium, hard in terms of let's solve with technology by graphing. So, what do you need to know for graphing? You need to know how to intersect. You always need to have in y2 the 0, so you have 2 equations. Now we're going to move down into the second type. There's three ways, remember. So the second way to solve an equation is by factoring, your favorite. So, factoring, there's 3 types of factoring we do. Everything starts, I'm going to put a little list over here. Our first step is always GCF. And remember, in your calculator, you can find GCF under the math, number, and then scroll down, okay, to help you with your GCF. I will show you how to do that in a moment. Second, after your GCF, what are we looking for? If we've got 2 terms, what are we looking for? Are they difference of squares? Does it look like x squared minus 16? If it does, we square root and open 2 brackets. X plus 4, x minus 4. That's if it's a difference of squares. Difference of squares means they have to be opposite signs. So one number's positive. In this case, it's the x. So x squared is positive. The 16 is negative. They have to be opposite signs. And again, equals 0. Okay? So that would be considered a difference of squares. But remember, these are my factors. These are not my answers yet. I need to remove them from the brackets and state my solutions. So, what does it mean by that? Well, what it means is what makes each bracket equal to 0. That's called the zero product property. So if I say what makes that bracket equal to 0, it would be -4, because -4 plus 4 gives me 0. Same thing over here. What makes this bracket equal to 0? +4. 4 subtract 4 is 0. So solving the equation is by creating whatever makes in your bracket create a 0. These would be the actual x-intercepts. The ones in the brackets are not the x-intercepts, they're the factors. Okay? So when they bring them out, they are opposite signs, always. Now, what if they've got a number in front of the variable x? Then it needs to come down as a fraction. So, for example, if I had 2x minus 3 in brackets, this would come out as positive 3, the opposite sign of that one, and then this 2 would come underneath as a fraction. That would be your final answer for there. Okay? And that's always if there's a number in front of x. Okay? If there's no number in front of x, don't worry about it. We just pull them out of brackets. Okay? All right. So let's take a look at these ones for factoring. So in our factoring steps, we either have GCF, and we always GCF first if we can. If we have two terms, we check and see if we can do it a difference of squares. Sometimes all you can do is GCF. That's okay. Third thing is if you've got 3 terms. If you've got 3 terms, you need to do the diamond. Okay? So let's take a look at each of our sections. The very first one is a difference of squares. How do I know? Because both of them, if I square root them, they give me a whole number answer. They don't give me a decimal fraction. So that's how I know it's a difference of squares. So you're going to square root both numbers, open 2 brackets, and now we're going to insert our x starts the brackets, and to end our bracket, we square root 25. The square root of 25 is 5. We separate our brackets with a plus and a minus. Equals 0. And, pardon? Yes, because it's an equation. So it has to have an equal sign there somewhere. So now we're going to pull them out of brackets. They're just going to be opposites. So we could say it this way, x equals plus and minus 5. And that could be our solution. Okay? Whenever they're identical but opposite signs. Plus and minus works just fine. The next one does not equal 0. So we're going to have to move that 6 to the other side. So we want it to equal 0. So we're moving the 6 over by subtracting it. So we're going to have x squared minus 1x minus 6 equals 0. You don't have to show the 1 in front of the x, but I showed it there just so you don't forget he's there. So the next thing we're going to do now, I check 3 terms. I can't GCF anything, so I'm down to my diamond. On my diamond, the top is always the A number times the C number. The bottom is always the B number. So I have a hidden 1 in front of my x squared. 1 times negative 6 is negative 6 for my top number. My B number is a negative 1. So now, I'm just going to remove our rules here so that I have more room. Now we need to make factors of that top number. So the factors of negative 6. So over here, I'm going to make a chart of negative 6. Well, 1 times 6, 2 times 3. How do I know which number gets the negative sign? The B value down here tells you. If the B value is positive, the big number would be positive. So the B value tells you which number gets the negative sign. So here, the B value is negative, so the big numbers get the negative sign. So now when I take a look at them and I add them, I'm going to get 2 and negative 3. So I have 2 and negative 3. These are called the wings of your diamond. And on the wings of your diamond, you need to now put those into brackets. So we're going to open 2 brackets and make it equal to 0, of course. X always starts your bracket. And now the numbers from our diamond are going to go into the brackets. So I'm just going to put them in order. Positive 2. This guy's going to come in. Minus 3. There's our answers. When we take them out of brackets to solve, then we would switch, yes. So the diamond numbers go in exactly as they look. So we put them in brackets exactly as they look. They are not our solutions. But now I would pull them out of brackets. So in this case, x is equal to a negative 2 and positive 3. Because what makes this bracket over here 0? What would I put in for x to create 0? A negative 2. Negative 2 plus 2 makes 0. So that's called the solution to that bracket. Then I look at the next bracket. If I put a 3 where x is, 3 subtract 3 gives me 0. I've solved that bracket. We're trying to create 0 in our bracket. That's what solves our equation. So that's how I get the negative 2 and the positive 3. Okay? They have to be opposites. The last question, letter C. I'll give you a moment to write this down. Push pause now and play when you're ready. The difference with this question is we've got a number in front of x squared now. So, again, in order to factor, we need to have ax squared plus bx plus c equals 0. It must be in this general form for us to factor. As we see, yes, we're in general form. But if we have a number in front of x squared, that's going to change how we factor it. So, I look, it's got 3 terms, I need to do a diamond. So when I do a diamond, it's going to be my a number times my c number. My a number is a 3, my c number is a negative 2. That's giving me negative 6. Now I have a positive 1 on the bottom for my b value. So now, I need to find the numbers on my wings. We just did a question like this, where it gave us negative 1. If I use 2 and 3, one of them's got to be positive, one of them's got to be negative. The number on the bottom, the b value, he tells you that the big number is going to be the same sign as him. So what sign is that one on the bottom there? He's positive. So he's saying, okay, big number, you got to be positive. So that means my 2 becomes the negative. Okay? Now I need to open 2 brackets. So I'm opening 2 brackets, make it equal to 0. Now, normally we would start our brackets with x. But this time, we have a number in front of x. So because we've got a number in front of x, we have to factor it into those 2 brackets. So what numbers multiply to give us a 3? Just 3 and 1 when you multiply. So that means one of them has to have a 3 in front, and one of them has to have a hidden 1 in front. Okay? We're used to the hidden 1s. That's okay. But we have a number 3 now. All this does is it changes what we do with our diamond. We have one extra step. We need to take our diamond now, and we're going to divide it by these numbers we put in front of A. So, the 3 and the 1. How do we know who to divide by? Okay, they're going to go in the opposite brackets, absolutely. That's right. It's whoever doesn't create a decimal answer. If I take the 3 and divide it by 3, I don't get a decimal. But if I take 2 and divide it by 3, I get a decimal. So that's why the 2 won't divide by the 3, the 3 will. So the 3 divides by 3, and I get a 1. The 2 is just going to divide by 1. Okay? So now when I put in brackets, I put their answers in brackets. They cannot go in the bracket of the dude they divided by. So this guy right here divided by 3. So that positive 1 cannot go in this bracket. He must go in the other bracket. So he's going to be positive 1. The negative 2 then only has one choice. He's got to go in the other guy's bracket. Okay? So that would be our final answer. Now we need to take them out of the brackets to find the solution. So remember, this isn't the solution yet. So when I take the 1 in brackets with only a digit 1 in front of x, okay, so I'm going to take this guy out of brackets, the very one on the far right. When I take it out of brackets, what would create a 0 in that bracket? Something plus 1 gives me 0. Negative 1. So negative 1 plus 1 gives me 0. So you take it out as its opposite sign. The next guy over here, I'm going to do the same thing. You take out the opposite sign. So negative 2 becomes positive 2. But this guy's got a 3 on the, underneath, or by the x. So he's got to come under and create a fraction. So x is actually equal to 2/3 and negative 1. Those are the actual solutions. And you can check your work when we do it on the calculator. Okay? So remember, if there's a digit in front of x, he's got to come underneath when you're creating your solution. Okay? And like I said, you can always check your graphing in the calculator. The next view is the third way, as we have three ways to solve equations. First way, we graphed it, found the x-intercepts. Second way, we factored, found the x-intercepts. Third way is our famous quadratic formula. So, we are now going to switch to the quadratic formula. I will write the quadratic formula up for you so that we always have it. You never have to memorize it. You will always be given it. It is x equals negative b plus and minus square root b squared minus 4ac, all divided by 2a. Now be careful. A lot of people are only dividing the radical part by the 2a. It's the entire top that divides by the 2a, so be very careful about that. All right, now in order to use the quadratic formula, you need to have it in general form. So that's a little must we have to put here. The equation, EQN, is my short form for my word equation. So my equation must be in general form, which is ax squared plus bx plus c equals 0. If it's not in general form, you cannot use the quadratic formula. It's as simple as that. It's one or the other. So if you can create general form, then you can use your quadratic formula. So the first thing you do when you look at an equation is we're going to label the a, the b, the c. So we're going to label a is 1, our b is 4, our c is 7. At the beginning, the negative b here, all that's showing is do the opposite sign of b. That's all it means by negative b. So put b in as opposite. So right now in the equation, our b value is a positive. I'm going to put him right here at the front as a negative 4. So he's going to look like this. X equals, I'm going to have negative 4 for my b, plus and minus. Now I need my b squared, always in brackets. Minus 4 times a times c. The a number is a 1. The c number is a 7. The next thing we know on the bottom, a number is a 1. All right. So now we're going to actually solve what's under the radical sign. Radical signs behave like brackets when it comes to BEDMAS, so you must solve under them first. So this is going to become x equals negative 4 plus and minus root. Here we're going to get, from this guy, we're going to get 16. From all of this, we're going to get negative 28. So 16 minus 28 is going to give us a negative 12. And at the bottom, we're going to have a 2. All right. Are we able to type that in our calculator? I see some heads shaking and I see some heads nodding. There's a trick in here. Does anybody see it? That's right. There's a negative under our radical sign. Are we allowed to have negatives under a radical sign? No. So at this point, oh no. Okay, there it is. Okay, so when we take a look at under our radical sign, we have a negative. The minute we see a negative sign under our radical sign, we can stop right there and we will say no solutions. There's no solutions because this equation won't touch the x-axis. That's why. So we say no solutions, or you could say extraneous. Extraneous means the same thing. Okay, so this guy's got no solutions. So all it tells us, remember, is about the graph, he does not touch the x-axis. That's all it tells us, okay? There are other examples for you to choose to try. We're going to move on to the next section. The next step. This one is saying solve the roots. Solving the roots from 3 different ways. This has already done the hard part for you. They've done the factoring in A and B. So for A and B, they've done the factoring for you. All you're doing is what makes each bracket equal to 0. So you're taking them out of brackets. So in this case, what makes this bracket equal to 0? Positive 2. What makes this bracket equal to 0? Negative 9. So the solutions on A are 2 and negative 9. When I look at B, what do we notice is in front of X? Coefficients. We have numbers in front of X. The minute the coefficient is a digit other than a hidden 1, that's when we have to create a fraction for our answer. So the digit's going to come out opposite side, of course, like we always have. And then the number in front is going to come under, like a fraction. Okay? Nope. The outside coefficient has nothing to do with the solutions. Okay? Unless there's an x with the coefficient outside, we ignore it in terms of finding a solution. This guy's going to come out with his negative 9. Then the number in front of x is going to swing down and create a fraction for him. Okay, and that's how we're going to get our solutions here. Now, the second one, negative 9 over 2, will create an exact decimal. You're allowed to use the exact decimals, that's fine. So our solutions here would be 5 over 6 and negative 4.5, or you could just say negative 9 over 2 is fine as well. Okay? We look at letter C. Letter C says, state the solutions given the following information. So what makes this difficult? Does it look like we can find our solutions looking right at them? Well, we're not sure. Let's take a look. You need to look at the window. The window says we're going from negative 10 to positive 10, but look at the scale. What is each one counting by? They're counting by 2's. So each notch is counting by a 2. So that means the first one there that I drew right here is negative 2. Then we get negative 4. Then we get negative 6. Okay? So the solution on the left is between negative 2 and negative 4. So what do you think that one became? Negative 3. Good. So we have one of them that's negative 3. Now if we look at the next one, let's take a look right here. We have positive 2 being the first one. What's between 0 and 2? Positive 1. Good. So the one that's in between there is positive 1. So x equals positive 1 and negative 3. So again, we have to look at those scales to find out what they're counting by, because each of those notches, your increments, if they're counting by different levels, it's going to change where it touches the graph. Okay? That's why. So what makes it a difficult question? The scale. What it counts by. Okay, so what is it counting by? This one was counting by 2's going left to right. 2, 4, 6, 8. That's what each of those notches were. Okay? Now we're going to take a look at the bottoms. We're going to talk about the numbers of solutions. How many solutions did something have? Quadratics have 3 different solutions, 3 different situations. So, 2 parabolas that have no solutions. No solutions, I'm going to show you A. On here, we'll do A is going to be blue. No solutions, it could be above or it could be anywhere below. It means it is not touching your x-axis. Okay? If it doesn't touch your x-axis, it has no solution. Okay, so that's letter A. So 2 parabolas. One's going up, doesn't touch x-axis, one is pointing down, doesn't touch the x-axis. Some graphs have two solutions. So on a different graph, I'm going to draw it down here, and this is letter B. Two solutions means it's going to touch the x-axis twice. So my x-axis, I'm just going to draw in green here, and we need to touch it twice. So we could have a parabola going up, and we touch twice, or we could do that in reverse, make it go upside down, and you could touch twice as well. Okay? That is letter B. So why do some have two solutions? Because they touch x twice. That's all. So if you want to write it, B/C is because. So because it touches the x-axis twice. That's why it has two solutions. It's all about touching the x-axis. Letter C says, develop an equation that has one real root. If it's got one real root, that means it only touches the x-axis one time. So that's those, I call them Snoopy nose. So here's my letter C we're going to draw on there. So a Snoopy nose would be something like this. He's going to come down, touch the x-axis, and take back off. There's my Snoopy nose. Okay, so he touches once. Then I'm going to draw another Snoopy nose going upside down. So he could come up like this, touch the x-axis, and take back off the other way. So that's another situation where it would touch the x-axis once. Okay, so how do we know if they're going to touch the x-axis once or not? How we know is if their brackets are identical. So for letter C, I could have an equation like this. X plus 2, x plus 2. Well, that's going to be minus 2. It's going to touch minus 2 twice. So that's this first one here on the left. That's this guy right here. Right there. This one, I could write it as x minus 3 squared. Y equals x minus 3 squared. Well, x minus 3 means it's going to touch positive 3 twice. Well, if it's touching positive 3 twice, that means it only actually literally touches it once. So, if the brackets are identical in every way, they are going to be touching once. If the brackets are different, completely different, it will touch twice. Okay, that's the difference. So for letter B, when it touches twice, his brackets will be different. Okay, both brackets different. If it's going to touch only once, both brackets are identical. Okay, that will always hold true. All right. Now we're going to create an equation based on the x-intercepts that they're going to give us. Okay? So if we take a look at the next outcome, it says express a quadratic in factored form given your zeros, meaning x-intercepts, for your function. So we're always going to start with y equals. So we're going to say y equals, I'm developing an equation, and it wants it in factored form. So I'm going to show two brackets. Now it tells me that it's got a root, which is an x-intercept, of -5, positive 8. Well, I'm going to put in my 5 and my 8, and you guys are going to tell me what sign to put with them. If I put the 5 in a bracket, what kind of 5 does he go in as? A positive 5. If I put my 8 in, what does he do? -8. He's opposite. Good. And who's always starting our bracket? X is. Good. Perfect. So there's our equation. Well, if they don't tell us one and they don't give us another point to find out the equation or create it, then they just say A is 1. Okay? Now, this one's saying develop one with whole numbers with zeros there. So again, this one now is telling us that A is 1. So we're going to have this again. And two brackets. What makes letter B a little bit more difficult than letter A? Fractions. So the fraction was created because there's a number in front of x. So that means in front of my x, I'm going to have to place a digit. So, how do I know what digits go in front of x? The guys on the bottom. Good. So I'm going to take my first one. I'm going to take -1/2. The bottom number is going to sit in front of x, and the top number is going to go in as the opposite sign. So it's a -1. It's going to go in as a +1. Okay? The negative sign on the side will always float to the top number. Okay? It's always going to go to the top number. That's only if we're taking them from a diamond. Okay? This one is just stating it for us. Okay? All right, going into the next bracket, I need to take my 7 and my 5. My 7 is going to sit at the end, and my 5 is going to sit in front of my x. Now, what kind of 7 is going to go in the bracket? A -7, good, because he's positive here. He's got to go in as his opposite sign. Okay? So the only difference between A and B is I've got a number in front of my x. Okay? And that number comes from the bottom. All right. The next one is telling us it's got decimal numbers. So the first thing we're going to do with our decimal numbers is we're going to math frac them. So first thing we do to this guy, 3/10, math frac. First thing we do to this guy, math frac them. So you're going to have -45/100. That reduces. Okay? 3/10 is reduced. -45/100 should go into -9/20. All right. So the ones we're going to use are 3 and 10 and -9 and 20. We're doing the exact same thing as we did in letter B. So we're going to open two brackets. Y equals, open our brackets. We need to stick an x in, but we're going to have a number in front, so leave room. So my first one is 3/10. What am I going to do to put it in that bracket, 3/10? Where does the 10 go? Front of the x, good. The 3 obviously goes at the end. Now, he's a +3, so in the bracket, what kind of 3 does it become? -3, good job. All right, we're going to do the exact same thing with the -9/20. So, which digit sits in front of x? 20, good. Then we're going to have the 9. He's negative outside, so putting him inside is going to go +9. Okay, and we've created our equations. Push pause down, play when you're ready. Okay, the very last section for Unit 2 is problem solving. With problem solving, what you're doing is you're always taking the equation with your calculator and you're putting it into y equals. So, in the very first one, you're going to notice, find your equation, first thing you do, grab your calculator and throw it into the y equals. Okay? So that's the very first thing you do. Now, it wants us to sketch a diagram. When we sketch a diagram, we've got a juggling guy here. He's tossing a ball into the air and he's letting it drop on the floor. So, if we are going to sketch it, he is going to be sketched something like this. Now, he's not starting at 0, 0. What is his y-intercept? 1.5. We know that because it is the c value in the equation always. So I know my y-intercept is right here at 1.5. We don't know where he hits the ground. Every problem-solving question is typically going to ask you for a maximum point or an x-intercept. Okay? So, this case it says, how many seconds does it take for the ball, how many seconds to the nearest hundredth is the ball in the air? Well, the bottom is your time, and top is height. So time, if you want to know the entire time the ball was in the air, that means you want it from point A starting until it hits the ground. So that means you need to find the x-intercept, and that tells you how long it was in the air. Okay? Because it was this entire duration. So, in the calculator, we're going to throw in our y equals negative 4.9 x squared plus 12x plus 1.5. And we'll graph it. So we're going to hit zoom 6 so we can see our graph. And now we want the x-intercept. So again, we have in y2, we've got our 0, so we can intersect it to find it. So we're going to hit second trace. We're going to hit number 5, intersect. Now, it's going to find where it's on the left. So we have two x-intercepts here. One's at 0, 0. Or actually, it's not 0, 0. It's 0 and whatever that is. 1.5. But we've got to get the other guy. We want the one on the right-hand side. So that means we've got to move our cursor over halfway. So start using your right arrow and move your cursor to the right. Anywhere over halfway. And then you're going to hit enter 3 times. So we find our intersection, round to 2 decimal places unless they ask you otherwise. This question does ask for 2 decimal places. So I look at the third number. That's the number that's going to round the second number after. So the 8's going to round the 6 to a 7. So 2.57. So we say that x equals 2.57. So that means the ball was in the air for 2.57 seconds. Okay? And that's typically all we are trying to find here. The next question I'm going to leave for you. It will be done the exact same way. We're now going to switch gears into Unit 3. Unit 3 is analyzing the equation. So Unit 2 is all about solving x-intercepts. Unit 3 is all about finding max, mins, and the xy intercepts. Okay, so we're actually analyzing different parts of our graph. All right, moving on. Unit 3. So the very first thing, whenever we want to find a y-intercept, this is considered general form. We have 3 forms. We have general form, factored form, which we're used to seeing, and then we have vertex standard form. So vertex form is when we've got our a and our p and our q. Here we've got ax squared plus bx plus c because it's general form. So in general form, to find the y-intercept is always the c value. So here the y-intercept, a y with a baby I is the symbol for y-intercept. So the y-intercept is -9. If you write it as a coordinate point, it would be 0, -9. This question here is asking for x-intercepts. We just did a situation like this. All of Unit 2 is finding x-intercepts. So you have one of 3 ways: graphing, factoring, quadratic formula. So in this case, we're just going to throw it in our y equals in our calculator. When we do that, actually I'm just going to factor it for you. That's a little bit quicker here. We're going to go x plus 4 and x minus 1. All right. The reason I know it is that is because if I do my diamond, I've got a -4 on top, +3 on the bottom. The only way to get that is with a -1, +4. So my -1 and +4 from my wings of my diamond, they go into my brackets. Okay? But remember, the brackets aren't the x-intercepts. Now I got to take them out. So, taking them out, x equals -4, x equals +1. Remember, we're always taking them out of the brackets to see who they equal to. The next one. This one does not want us to use a calculator. We want to do it by factoring. What is the first step for factoring we should always do? GCF. So we're going to divide this by 3 to begin with. So we're going to get 3x squared plus 7x plus 10. And of course it's y equals. Now we need to factor that as a diamond. What multiplies to 10 and adds to 7? There's only 2 numbers. What are the factors of 10? 2 and 5. So we're going to have y equals x plus 2, x plus 5. Okay? The 3 only, well, the 3 does tell us something. The 3 is our a value, and the a value is going to tell us whether it is going up or down. So the 3 is positive, so which way is he pointing? The tails are pointing upwards. So the direction of opening is up, he's pointing this way. Okay? And the 3 also tells us whether he's narrow or wide. So what does the 3 tell us in this situation? He's narrow. Good. If the number's bigger than a 1, it's narrow. All right. The min or the max point. Do we know the min or the max point yet? No. We need to find that from our vertex. Now, can we find our axis of symmetry? Yes. Anytime you have x-intercepts, you add your x-intercepts and divide by 2. That's your axis of symmetry. So I need to take these guys out of brackets and find my x-intercepts. So my x-intercepts here are -2 and -5. So I go down here and fill out my x-intercepts, -2, 0, and -5, 0. Okay? Now, the rule is to find the axis of symmetry, you add the x-intercepts and divide by 2. So for my axis of symmetry, I'm going to have -2 plus -5 all divided by 2, which is -7 over 2. So our axis of symmetry is at -3.5. So back down here, axis of symmetry, x equals -3.5. Because we need to graph that. Now right now, the -3.5, the axis of symmetry, that's our x number of our vertex. So we know that our vertex starts with, I'm just going to put it over here, our vertex starts with -3.5, comma, it's going to be a min in this case, our min point. So we don't know our min point yet, okay? The only thing we need to do with this question is graph it to find the min. So, domain, what is the domain unless it's problem solving? X is an element of the real, XCR. How do I find my y-intercept if I don't have my calculator?
The last C value?
It's the constant, the c value. Good. So my c value is +30. I always go to my original equation. So my y-intercept is at 0 and +30. Okay? So when you factor an equation, you can find everything about the equation except for its minimum or maximum point. Everything else you can find. You can even find the x value of your vertex. The only thing we can't find is the min-max. So this is where we have to go to our calculator now. So everybody grab your calculators. We're going to turn it on. We're going to open our y equals and put our new equation in. So in the y equals, we put the original equation, 3x squared plus 21x. Whoops. $21x, there we go, plus 30. Okay, if we have that in there, and I'm going to hit graph, I can see my min point on the left. So I'm going to hit second trace. How do I find my minimum? I go down to number 3, minimum. Okay? Now, you always have to be to the left of the lowest point, then to the right. So when it says left boundary, look at where your x is. I'm at 0, so I'm way over here. So I need to move my cursor to the left. Okay? So I need to be left of the lowest point, hit enter. Then you move your cursor to the right of the lowest point, anywhere right, and you hit enter twice. So we already found the axis of symmetry, -3.5. Our minimum point now is -6.75. Okay? So now the rest of our vertex here is going to be at -3.5 and -6.75. Okay? So we found our min point. The min point is the y value. Okay? Everything we've done in Unit 3 is all about analyzing equations. So we analyzed it in general. Now we've got to analyze it in vertex form. So vertex form is also called standard form. Okay, so let's take a look at our next question. These ones are talking about finding your axis symmetry when they tell you the x-intercepts. So just to do a quick question for you, these ones, you're going to add the x-intercepts, add them, then divide by 2. Why divide by 2? Because you're finding the average of 2 points. So in this case, negative 2 plus 2 is 0. Divide by 2 is 0. So this guy's axis symmetry is at 0. Okay? I'll let you write that down. We're going to move on. So that's finding axis of symmetry. Now we're going to move on to the vertex form. If we have vertex form, our vertex form is always written y equals a x minus p squared plus q. Now p and q could also be used as h and k. It depends on what you see in each question. Now, the vertex comes from the letter P and the letter Q. Notice in the brackets P is negative. In the vertex bracket as a coordinate point is positive. So when you pull this P out of his X bracket, he will turn to positive. That's how we have a positive P out. Q never changes his sign. Q will always be what he is. So when they ask us to label a point and they tell us our vertex, they're giving us the x, y, p, q numbers so that we can find the a number. So all it is substituting numbers into this equation for y, x, p, and q. So that's exactly what we're going to do. But our first step is to label who's p, who's q, who's the x, who's the y. So first thing we do is look at the word vertex. Okay? I find the word vertex, so the point after it is my P and my Q. Then they're just telling me a generic point, point A. So that's going to be my X and my Y. So now I know my digits, I'm going to start plugging them in. So my Y is 15.5 equals the A value, which I don't know yet. My X value is my -3. And from my vertex point, my P number comes in as the opposite, so he's coming in as a -2. The Q is coming in as its normal sign, +3. So we've got absolutely every digit plugged in where it belongs. Now we just do BEDMAS. So the first thing we're going to do is we're going to move the Q to the left. So we're going to move that +3, and he's going to go all the way to the left with the 15.5. So we're going to subtract 3 from both sides. I'm going to rewrite it down below just because there's space. So I'm going to get 12.5 equals A. And in brackets now, I need to solve my bracket. -2 and -3 give me a -5. This -5 squared, any number that's negative in this bracket, will always square to become a positive. So remember that. A negative in this bracket squared will give us a positive. So now it becomes the coefficient of A. So we have 12.5 equals 25 A's. And now we literally just divide by the number in front of the variable A. So now I'm going to divide by 25 to both sides to get rid of it. And now I'm going to get A is equal to 0.5. A is equal to 0.5. So now I go up to my generic equation and I rewrite it with my x and y as x and y, but I put my A, my P, and my Q in there. So I'm going to use the red equation up here and I'm going to rewrite it. Y equals x squared. Now I need to put in my A, my P, my Q. A is 0.5. You could use a fraction and put 1/2, that's fine. My P number in brackets is a -2. My Q number is a +3. So this is the equation in standard form. If they wanted that in general form, and if it's multiple choice, let the questions help you. All you do is you put this original equation in y1. In y2, put what they have for an equation possibility in section A, because you're going to get A, B, C, D choices. Graph each one of them. If you only see one graph, that means it traced it perfectly, which means it matches. Okay? All right. Let's move on. The next one's talking about an arch. The archway, we can create an equation knowing the max, mins, and the length of our arch. So, in this question, we have a maximum width of 10 feet. So that tells us that we're going to be having 10 feet. We have an arch. So from here to here is 10. Okay? So that means our x-intercept is 10, because it's 10 feet. And it starts at 0. Yeah, problem solving always starts at 0. And then it says a maximum height of 12. Well, we know our max height over here is at 12. So our maximum point, our vertex, is something 12. Because we know our max. Well, we know one x-intercept 0, the other x-intercept's 10. We also know our axis of symmetry. If we know two x-intercepts, it's just halfway between. What's halfway between 0 and 10? 5. Good. So we know our axis of symmetry is 5. So now we've got our P and our Q. We've also got two x-intercepts. So you can choose to write this in vertex form or factored form. Okay, it doesn't matter. I'm going to choose vertex form since they gave me the vertex. So I'm going to have y equals ax. I take my P and put it opposite, minus 5 squared plus 12. Now I use either this point or this point as my xy numbers. So I'm either going to use 0, 0, or I'm going to use 10 for x and 0 for y, because that's my numbers that I have here. Okay? So I'm just going to use 0, 0 to keep it simple. That's this guy right here at the origin, 0, 0. So y is 0, x is 0. Now I'm going to do the same thing. 12 is going to go to the left, so I'm going to minus 12, minus 12. Equals a. What's 0 subtract 5? Negative 5 squared. So we've got negative 12 equals 25a. Now what are we going to do? Divide by negative 25. Yep. Divide by positive 25. Thank you. We're getting a negative answer, so we're going to get a is equal to negative 12 over 25. It will not reduce. So this you would put in front, right up here, and that would be your equation. This concludes the review for Unit 3.